Good day, everyone. Today we will talk about binary subtraction. Take note of these four rules for binary subtraction before we start. So we have them simplified in one table. This is for input A, for input B, this is the result, and this is if we need to borrow a number. So 0 minus 0 is equal to 0. 0 minus 1 is equal to 0, but then you will borrow 1 from the next more significant bit. You will see this later in the example. Then 1 minus 0 is 1. 1 minus 1 is 0. There's only one instance where you can get the number or the result 1 right away. It is only when you subtract 1 and 0. But take note that in this case where you will need to borrow, say in 0 minus 1, since you need to borrow 1, that will affect on the result or the difference. You will see that later in the example. So what are we waiting for? Let's now check the example or examples that we have. I'll start with the very first example. This is 170 minus 162. The answer is 8. This is the conversion to decimal. By the way, why are we using base 10 here? Take note that the use of base 10 in converting binary to decimal is constant or radix 10. And also take note that decimal is represented by 10 symbols, which are numbers 0 to 9. Again, radix 10 here is constant when we convert binary to decimal. Now let's go to our example. We have here 10101010 minus 10100010. By the way, the ones highlighted in red or the one highlighted in red is the result. Now class, let's solve it. When you solve subtraction, you solve it from right to left. Let's start. 0 minus 0 is 0. That is based on the rule. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. If you check the rule again, you can get an answer 1 right away when you subtract 1 and 0. So 1 minus 0. Let's go back. Then we have 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 1 is 0. You got the answer 1, 0, 0, 0. Miss, what will happen to the other 4 zeros? By the way, class, if your zeros are before 1, that will not change the value of your binary digit if you remove that part. So you can just answer 1, 0, 0, 0. Although it's still okay if you include the 4 zeros here, but then again, it's not necessary. Any zeros before 1 actually does not change its value or the value of the number or binary digit. Binary numbers, sorry. Now class, if you check on that, if you check the result, it is actually equivalent to the decimal 8 radix 10. This one is an easy example. Let's check another example. So we have here 168 minus 162. It is equal to 6. And these are the binary conversions which we will also subtract. This is 1010 1000 minus 1010010. Again, we will solve it from right to left. And to remind you again, according to the rule, the instant or the time where you will get instant 1 is when you subtract or when you do 1 minus 0. But then again, when you do 0 minus 1, you will borrow 1 to the nearest number with the value 1. Okay? Or to the nearest number, yes, with the value 1. And then class, that may change the result or the difference. Let's check this example for you to better understand it. We have here 0 minus 0 is 0. Now here comes the problem. 0 minus 1. According to the rule again, when it's 0 minus 1, you will borrow 1. So 0 minus 1, we need to borrow 1 now. I need you to focus on this part because this is kinda complicated. So here class, we have 0 minus 1, so we borrow 1 from here. I will highlight, we need to borrow 1 from here, sorry, but this is 0. Therefore, we cannot borrow anything. So we look into the nearest number 1, so we can borrow, and it's here. Now when we borrow 1, it has to pass to the other zeros first before it can reach the last 0 here. Now we still have 0 here, so it has to pass by here. So when I'll borrow 1, it has to go here first. This now becomes 1 0. And 1 0 class, you have to take note that the equivalent of 1 0 in decimal is 2. So you now have 2. But then, that doesn't solve the problem yet because you need to borrow another 1 for this 0. And since this is 2 class and I lend my 1 to this 0, what happens now? Does it become 0 again? Of course not, because again 1 0 is 2 and I will only lend 1 to the 0 beside me. So this now becomes, so let's put the 1 here because I'm lending 1 to this 0. Yes. So this one class will now become, what do you think? This will now become 1. It won't go back to 0 because of course I'm just taking 1 from 2. Therefore, you still have 1 left. So this one class will now have a value of 1. So now I have 1 0 here. It now becomes 2. Why is it 2 class? When you convert 1 0 to decimal, the value is 2. So if you subtract 1 0, which is 2 in decimal, minus 1, the answer is what? 2 minus 1? 1. That's why we get the answer 1. So we're done. We're done with this part. Now let's solve this part. As I said earlier class, it won't go back to 0 since 1 0 is 2 and you just lent 1 here. Or you were just able to lend 1 here. Therefore, you still have 1 left. 1 minus 0 according to the rule is 1. In this case class, why did we have 0? Because originally this is 1. And then we lend, or this one actually was able to lend 1 to this 0. So of course class, 1 minus 1, because you lend 1 here, 1 minus 1 is 0. That's why this became a 0. So 0 minus 0 is 0. Now class, 0 minus 0 is 0, 1 minus 1 is 0, 0 minus 0 is 0, 1 minus 1 is 0. So we got the answer 1, 1, 0. If you convert that, that's equivalent to 6. As I mentioned earlier class, the other zeros before 1, if you remove the other zeros before 1, that will not change the value of the binary number. So it's up to you if you want to include this, but if you don't want to include this, say in this case you will just use 110, that's perfectly fine. Again, the technique for you to know if you are able to answer it correctly is to convert the binary digits to decimal and check if your difference matches with the difference of the decimal conversion. So that's all for binary subtraction class. I hope you're able to learn something today. Thank you.